Alrighty guys, I just made a new video going over the study guide because I wasn't too happy with how I thought the Google Meet went good yesterday. I don't think it's saved very well. So um and I don't think it looked as well as it will from this point of view. So um use the figure to the right, name the line that contains the points Q and R. So first thing I'm gonna do is I'm gonna highlight Q and R. So there's Q and there's R. Alright. So the line that contains those points is this. Any 2 points make a line, but that's the line right there. That's that little lowercase a. It's called a script A. So you could just write line A. That's a name. It's not a point. A is not a point. That's how they name the line. Another way you could write the name of the line, you could put R and Q as long as you put a double arrow over top. It has to be a double arrow. Remember, we use segment notation when we were doing proofs. That was just a straight bar, and a straight bar is different than a double arrow. You could do QS. All right. You could do RS. All four of these are the same. These are all the same. There's just four ways to write the same line. Okay. 2 points that are coplanar with W, X, and Y. So we have 2 points that are coplanar. Coplanar means on the same sheet, almost, is kind of looking at it. Plane is a flat surface that goes in all directions. So in this picture, to the right, this is the name of the plane. That is not a point. That's just talking about the three-dimensional space. That's talking about like this part, right? Now they write it as a shape, but really it goes on forever that direction, forever that direction, forever that direction. It's like, think about a wall that would go up forever, to the right forever, that would go on forever. So it's not exactly the same as a three-dimensional shape or as a two-dimensional shape, because it's not closed. We just, a lot of times we'll just write it as a closed shape when we do this. So as long as it's on that same surface, then it is coplanar. So I'm going to highlight points W, X, and Y. So W, X, and Y. So I notice that Z and Q are on the same plane. I could not write down R or S. Okay. Give another name for plane WQY. So 3 points. So plane WQY is these 3 points. So you could just say plane P. Now it's like a fancy P. It's like a script P. It's like a cursive P almost. You could also say plane 3. You could do any 3 points on that plane. So I could do plane WZX. I could say plane QYX. Right? Now I'm going to find lines B and line C. So here's line B, here's line C. So where they intersect, right there, is point Q. Alright, that's it. Alright, 16. Find the variable if X is between P and Q. So the first thing I always do whenever I'm doing problems like this is I draw a figure. So I'm going to draw there's P and Q. Now I'm just saying X is in between it. That does not necessarily draw to scale. Remember, that's a big X, not a little x. So that is a big X. This is a little x. Two different types of x's. Now, now xq is 26. So I'm going to put 26 right here. So this part is 26. xp, that's 10x minus 6. So I'm gonna put 10x minus 6 right here. Now the whole thing is 80. So guys, all this writing is for 14a. I'm gonna erase that and do 14b in a second. So the segment addition postulate tells me that my red part, 10x minus 6, plus my blue part is going to equal the whole thing, which is 80. Now I have just a simple equation. I'm going to put my numbers together. So I have 10x plus 20 equals 80. I'm going to subtract 20 from both sides, so 10x equals 60. So x equals 6. Remember, that is the variable. Now I need to find xp. So to find xp, I got to plug in 6. So I'm going to put 10. Instead of x, I'm going to put 6 minus 6, which is 54. So that is xp. Alright, that's it for 14a. Now I'm going to do the same thing for 14b. And the same thing, I'm going to do the same exact thing to start. I'm going to start with the picture, and I'm going to do my best to fill it in there. If you ever get lost, start with the picture. So there's my picture. So xq is 3y plus 1, so xq right here. xp, 5y plus 37. The whole thing is 75. So the red piece plus the blue piece is going to equal the entire black piece. So I'm just going to write that. 3y plus 1 plus 5y plus 37 equals 75. Now I'm going to put my y's together, so I'm going to get 8y plus 38 equals 75. Now I'm just going to use PEMDAS backwards. So I'm going to minus 38 from both sides. So I get 8y equals 37. Now I'm going to divide both sides by 8. Y equals 4.625. Or 4 5/8. Now you could always check your work with both of these. On 14, you could plug in x for the variable, and you could see if it's going to work out. So you could always do that. Alright, we're going to start the second page. The key word for this video is Baby Fight Club. My babies are fighting each other, so keyword is Baby Fight Club. 15. Are CB and CD congruent? Name two other congruent segments. Remember, that means congruent. So, are CB, C to B, and CD congruent? Yes. Name two other congruent segments. Well, I could say that AB is congruent to CB. I could also say that AB is congruent to CD. Remember, you got to use the bars on top because we're talking about segments. And we got to use the congruency symbol because we're not talking about numbers. So you could also say AD is congruent to stuff. You could also say CD is congruent to stuff. Alright, now on this next one, I'm going to be using this stuff right here. Remember, A is 2, so I'm going to plug A in there. 3 times 2 is 6. 6 plus 2 is 8. So I have XY. I have XY equals 8 because I plugged in 2 right there. I'm going to plug in 2 right there. So then I'm going to have YZ equals 8. So since both XZ equals 8 and YZ equals 8, they are congruent. Alright, so find the distance in midpoint. So remember, guys, distance formula, I gave you that the other day. It's also on your pin page. So distance, that distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, all underneath the radical. Alright? So, I have to pick out, if I call this x1, then this has to be y1. Remember, x is first, then y. I could call it x2 as long as I call 1 y2. So I could call 3x2 as long as I call 1 y2. But I'm going to do this. So I label my stuff, and I'm just going to plug it in. So my distance is equal to the square root. x2 is negative 7 minus 3 squared plus negative 13 minus 1 squared. So I get negative 10 squared plus negative 14 squared. Remember, I want that in parentheses, especially with that negative. If you forget those parentheses with your calculator, it could give you the wrong answer. So I'm going to have the square root of 296. Because that's 100 plus 196. So the square root of 296. And when I plug that in, I get 17.2. Alright. Now midpoint, a little bit different. So midpoint, the distance would be the length of the from A to B. Midpoint is the halfway point. So the midpoint formula a little bit different. So you do x1 plus x2 all over 2. That finds your y value. Then you do y1 plus y2 all over 2. Make sure you do the top and bottom separately. Alright. So, I'm going to use the same exact thing. So this time I'm going to plug in x1 plus x2. So I'm going to put 3 plus negative 7 all over 2. Then positive 1 plus negative 13 all over 2. So I'm going to get 3 plus negative 7, so it's going to be negative 4 all over 2. Negative 12 all over 2. So my midpoint is going to be negative 2, negative 6. And that's it for 16. Alright, number 17. Once again, guys, to start with this, I'm going to draw a picture. There's F, and there's G. Now, I am telling you that M is the midpoint. That's important because that means I know this guy is congruent to this guy. Alright, we're going to use that later. So, FM is going to be 3x plus 4, so this piece is going to be 3x plus 4. And MG is going to be 5x minus 26, so this light blue piece is going to be 5x minus 26. Now, I don't know the whole piece, but I do know that 3x plus 4 and 5x minus 26 are equal to each other. So I can actually write this, 3x plus 4 equals 5x minus 26. So although it doesn't have anything to do with the distance, I can still find x because I have one equation. Now remember, whenever I'm doing one equation, I want to put all my letters on the same side. So the first thing I'm going to do is I'm going to minus 3x from both sides. So I end up with 4 equals 2x minus 26. You could put the letters on the left side. It's not going to really change anything. I just like my x's to be positive. Now I'm going to do PEMDAS in reverse. So I'm going to get rid of the subtraction by adding. So I get 30 equals 2x. Now I have to get rid of the multiplication, the 2, so I divide by 2. So x equals 15. Alright, so x equals 15. Now to find, so that's a variable, I did that part. Now to find the missing measure, that's FG, I have to plug in 15 here and here. So to find FG, I'm going to do 3 instead of x. I'm going to put 15 plus 4 plus 5 times 15 minus 26. Now, if I do this piece and that piece together, they should be the same thing. It's a good way for me to self-check and see if I did my stuff correctly to begin with. Because since they're midpoint, since m is the midpoint, those should both be the same number value. 3 times 15 is 45, plus 4 is 49. 5 times 15 is 75, minus 26 is 49. So that means FG is going to be 98. All right, that's it. All right, 18. Use the figure to the right, find the vertex, and rename the angle. So the vertex is always the point where the two lines meet. So angle 9. So I'm going to find angle 9 here. Angle 9 is talking about this vertex right here. So the vertex for angle 9 is G. All right. Now, if I were to do 9, 9 is this part right here. All right. So when you rewrite the angle, the vertex has to be written in the middle. So you can write angle HGF. You can go H to G to F. So you can go H to G to F, or you can write FGH. It doesn't really matter. I'm going to write FGH, but it doesn't. Like I said, it doesn't matter. All right. Now I'm going to find angle 4. Angle 4. See, it's talking about the vertex is D, because that is where the angle's at. That's where the two rays meet. So angle 4, the vertex is D. It goes from there to there. See, those two lines make up the angle. So I could say ADG. I could say CDG. I could say ADJ. CDJ. I could say JDC, JDA, GDC, GDA. So any of those are options. I'm going to just pick, we'll say CDG. So angle CDG. The biggest thing that I'm looking for is that this point right here should be in the middle. If that's not in the middle when you write it out, you're writing it incorrectly. Alright, so angle 3. Here's angle 3. Notice it's right. C is the vertex. So I'm going to go this way and this way. So I'm going to say C is the vertex. We'll say angle DCG. Remember, C has to be in the center. You could write angle GCD. You could write HCD. DCH are all options. Alright, angle 5. So I'm going to find angle 5. There's the number 5. So it's talking about this vertex right here, D. So D is the vertex for angle 5. Now notice it's using different points. It's using different lines or different rays. So we have E to D to G. So angle EDG. You could also do GDE, JDE, EDJ. Any of those are options. So that's it for 18. Alright, 19. If this is 22 degrees, vertical angles tells me that that is 22 degrees. Remember, vertical angles are congruent. So vertical angles are congruent. Remember, their vertical angles are across the street. So this angle right here is right across from that angle. They're the same. This angle is right across from that angle. They're the same. This angle is right across from that angle. They're the same. Now we also have some words that we need to know. For example, we need to know that complementary so that means because in supplementary so A to D makes a line, so that's 180. This right here means 90. That means these two angles right here, this angle and this angle together make up 90. So if this is 22, 90 minus 22 is equal to 68 degrees. So that angle is 68 degrees. Vertical angles tells me that angle right here is also going to be equal to 68 degrees. And this one is going to be 90 degrees. I like to fill in as many of the angles I can without doing much, without even looking at the question, just so I already know all that stuff ahead of time. So RXF. So I'm going to clear pretty much everything except the angle measures, just so I don't get confused later. So I'm just going to rewrite everything with just the angle measures, so I don't get confused when I start tracing angles. So I know this is 68 degrees, this is 90 degrees, this is 22 degrees, this is 68 degrees, this is 90 degrees. Alright, so now I'm going to talk about RXF. So RXF, so I'm going to find R, I'm going to find X, I'm going to find F. That is my angle from there to there. So 90 and 168, that's 158 degrees. So I get 158 degrees. Now, obtuse is bigger than 90. So this is going to be obtuse. So now, I'm going to do angle AXE. So I'm going to do angle AXE. A to X to E. Because it's 68 and 22 is 98 degrees. So this is 90 degrees, which makes it a right angle. Where right equals 90 degrees. Alright, FXD is my next one. So FXD, so I got F, there's X, and there's D, so F to X to D. That's 90 plus 1 plus 22 is 112 degrees. Now, I kind of was being sloppy. I should rewrite, when I write my angle, I'm being lazy, I should have wrote the measurement of angle RXF equals 158 degrees. Same thing here. I got to put a little m. That means the measure of angle AXE equals 90 degrees. I was rushing and just being lazy. So that is, notation should be done correctly. So when I write C, I should write the measure of angle FXD equals 112 degrees. And that is bigger than 90, so I do put the word obtuse there. Now I'm going to do FXE. So F to X to E, that's right here. So the measurement of angle FXE. So you got to have the little m because I'm writing a number answer. It's really important to have this when I'm writing a bunch of different answers at one time, so I can identify which one is equal to which. 22 is less than 90. So that is acute. And that's it for 19. Alright, 20 we're using this figure above, so we're using this picture right here to answer the following. Name a pair of non-adjacent. So non-adjacent means not right next to each other. Supplementary means 180 degrees. So I just need two angles not next to each other that equal 180 degrees. Well, this guy right here is 90, and this guy right here is 90. So I'm going to say angle AXR, it is not the only option, is congruent to angle, I don't know why, it is congruent, but that's not what I'm writing, and angle DXE. Like I said, that is not the only set. I could do a whole bunch of other options. So because this is 68 degrees, and this is 68 degrees, and this is 22 degrees, I could do RXF. That's because that's 158 degrees. No, it doesn't really work. I'm trying to think too that they cannot be right next to each other. So I think that's probably the best ones to do. So I don't know if there's an or not. If you think of an or, let me know. I think it's possible. Now, obtuse vertical angles. This one's a little bit harder because it's sometimes harder to see. So I know I got to find some obtuse angles. So the first thing I'm gonna do is I'm gonna pick this, right? Because it's 90 and 168. So I'm basically ignoring this line right here. I'm ignoring AX. Now, the angle that's right across from that is right there. That's also 158. So basically I have angle RXF and I have angle CXE. So they are across from each other. So this piece is across from this piece, and they are vertical. They are the same. If they weren't the same, there's no way they could be vertical angles. So it's good for 20. 21. Use X in the use the figure to the right and find X in the measure of the angles. So remember, vertical angles are congruent. So I get to say this guy is equal to this guy, so I'm going to say 62 equals 5x plus 2. I'm going to minus 2 from both sides. Because it's just a algebra problem. So I get 60 equals 5x. I divide both sides by 5, so x equals 12. There's the variable. I'm going to plug that in. I'm going to make sure that 5 times 12 is 60. So this is 62 degrees. These are supplementary. So this piece right here is supplementary to this piece, which means that's 180 minus 62 right there. So that's going to be 118 degrees, which because those other ones are supplementary or vertical angles, that's also 118 degrees. Alright, so perpendicular right here means intersect at 90 degrees. So that means all these angles are 90 degrees. That means what I have to have is this piece right here and this piece right there together have to equal 90. So I have to have 3x plus 4 plus 4x plus 2, and this has to equal 90 degrees. So now I'm just going to do I'm going to simplify first. So I have 7x plus 6 equals 90. Now I'm going to get rid of the addition by subtraction. So I get 7x equals 84. I divide both sides by 7. So I get x equals 12. Alright, now you can always plug it in. So if you want to plug it in to check your work, 3 times 12 is 36. 36 plus 4 is 40. 4 times 12 is 48. 48 plus 2 is 50. 50 plus 40 is 90. So I did check my work, and it worked out. That's going to finish one. I know it's kind of long, but we got up to 22 done now.